Our topic today is on building reuse. And for people working on reducing embodied carbon, remember embodied carbon is the greenhouse gas emissions associated from manufacturing, transportation, installation, maintenance, and disposal of building materials. We often ask, do you even need to build that structure in the first place? And if so, can you reuse something that already exists to minimize the materials needed for that new construction? Reuse is also significant because it reduces the enormous amount of construction waste generated by projects. And as we'll hear from Donald, building reuse has some social and community implications that are important for us to consider. So today we'll hear a little bit about all of those topics from our three fantastic speakers. And I'm just going to introduce all three of them right now. So first we have Larry Strain. Larry is the founding principal of Siegel & Strain Architects in Emeryville, California, known for community projects and innovative sustainable design and research. Larry's early work includes the Green Spec, one of the first guideline specifications for sustainable materials, and the Emeryville Resourceful Building Project, an affordable housing project that included an early use of whole building LCA life cycle assessment.
Goals and increase inclusivity.
He has led many of the firm's deep green projects, including 3 AIA COAT Top 10 winners. Larry has served on the boards of the Northern California chapter of USGBC, the Ecological Building Network, and the Carbon Leadership Forum, and was on the research team for CLF's Embodied Carbon benchmarking project. After Larry, we'll have Christian Kaczynski or Kaczynski. I'm always off on that, so I hope that when he starts, he'll be able to tell us how to pronounce his name right. Christian is the Associate Principal and Director of Sustainability at Bassetti Architects, a firm based in the Pacific Northwest specializing in educational and civic projects. With over 24 years of green building experience, Christian's work has included pilot projects for LEED and the Washington Sustainable Schools Protocol WSSP, as well as over 40 elementary, middle, and high schools certified under WSSP. His work has helped establish Bassetti as a leading K-12 firm that combines forward-thinking educational pedagogies, adaptive reuse of historic buildings, and a passion for health and energy efficiency. Christian is currently leading Bassetti's efforts to track and reduce embodied carbon across their portfolio, in addition to other priorities such as optimal daylighting for students, energy reductions, material transparency, and improved indoor air quality. Christian has previously served as a member of technical advisory groups for the Washington State Building Code Council, chair of the University of Washington's Department of Architecture Professionals Advisory Committee, and chapter president of the Northwest Eco Building Guild. And last, we have Donald King. Donald is an architect, planner, and educator with over 50 years of professional experience in the practice areas of architectural design, community planning, and project management. He has specialized expertise in urban design and planning, design of community-based projects, healthcare facilities, educational facilities, affordable family housing, and special needs housing. He is currently the CEO and president of the Nemi Initiative in Seattle, principal architect of Mimar Studio, and an affiliate professor of architecture at the University of Washington's College of Built Environments. Okay, so without further ado, I will pass it off to Larry and let him get started.
All right, let's see if I can do this. Here we go. There. Let me go to full screen. I hope you're seeing that now. Welcome. So just going to jump right in. You've probably all seen this pie chart. It's been around for a while, and it sort of shows this giant swath of buildings' impacts on global emissions, which is about 40%. And the point that I like to make with this chart is not about the operating or embodied, but about where they come from. And the point is that operating emissions are mostly, or actually all, from existing buildings, because you can't really have emissions until the building exists. And the embodied emissions are mostly from new buildings. So one way to bring those two numbers down is to reduce the operating emissions from existing buildings. And the other thing to do is if you reuse more of those existing buildings, you can build fewer new ones, thereby reducing the embodied emissions. So existing buildings seem like a great way to get at both of those numbers. The grid's getting cleaner. New energy codes are moving us towards net zero. There's a growing focus on reducing the embodied emissions from new construction, but a lot of these encouraging trends and codes are really focused on new construction. They don't address existing buildings, and existing buildings turn out to be the largest source of emissions from buildings. Let's see, I can get on this one. Okay, oop, go back. So reusing and upgrading existing buildings accomplishes two things. As I said, the upgrade part reduces current operating emissions, and the reuse part makes it possible to build fewer new buildings, thereby reducing future embodied emissions as well. But we haven't had a tool that could compare all of the variables of embodied carbon and operating carbon for different use and reuse scenarios. Retrofitting an existing building to net zero emissions will always be the lowest carbon option. But what if you can only improve its efficiency by 50%? What if you can replace it by a new net zero emission building? Does it still make sense to retrofit, or should you build a new one? And how does climate and grid efficiency affect those calculations? So we set out to design a simple tool that could compare all of the carbon emissions, operating, embodied, and avoided emissions of a building retrofit compared to a new replacement building. We wanted to be able to compare these emissions for a variety of existing, new, and reuse scenarios over different timeframes. The current version, beta version we have right now, compares average emissions of an existing baseline building, and then you select from a menu of retrofit options and select one of 4 new replacement buildings. Each scenario comes with different embodied carbon values, or you can enter your own data. And you can also select your target operating emissions for the new building and the retrofit. It's not really a design tool, although it can be used for early design decisions. It's a tool for planners, building owners, and developers for estimating the carbon impacts of reuse compared to a new building. So it's how you make the decision whether you're going to build a new building in the first place or retrofit what you have. We got a grant from One Workplace to work on this. We put together an advisory committee and got to work. All right. So let me start with what we have in there. We start with the existing building, and the existing building is all about operating emissions, because the existing building is our baseline. We're not doing anything to that building. It's just what would happen if you left that building alone. It just kept operating. So to get those numbers for our calculator, we use the CBEX database and the REX database, which is the Commercial Building Energy Consumption Survey and the Residential Building Energy Consumption Survey. And those gave us the baseline numbers for these different building types that you're starting with. Then we picked 4 different new building replacement possibilities. So we looked at, and each one has a different profile and a different embodied carbon. These were picked, really defined more by size, materials, and structural systems than by use. So there's a light wood frame building, a mixed wood, concrete and steel building. So this could be wood frame over a concrete parking deck, a mid-rise concrete and steel, and then a high carbon building, which could be a high-rise, super high building, or it could be a blast-proof building in Dubai. It could be anything you want, but it's a building that's high carbon. And each one of those comes with a different embodied carbon footprint. So you pick the one that most matches the building you're planning on replacing your scenario with. Oops, I'm off it again. Let's see if I can get back on here. All right. Then we developed a menu of retrofit and renovation upgrades. So we looked at different upgrades to the MEP systems, the envelope, the interiors, the cladding, and the structural system. And you sort of pick the level of upgrade your project needs. And each one of these tabs has a different embodied carbon number associated with it. So that's the next stage. And then the final stage is you pick your target operational emissions, your target carbon. So you have your existing building, which is based on the CBEX baseline of 2012. And you can pick the retrofit option. Are you going to be 20% better, or 80% better, or zero net carbon? And the same with a new building. And you pick those for each one. So then I'm going to show you how this all works. But this is the idea, is that you can get a quick take on whether it makes sense to replace the building or not. So this is what the screen looks like. And I'll walk you through it in more detail, but there's boxes over on the left that you can enter data, and they all have drop-down menus. And then as you enter the data, it charts out your emissions for the existing building, do nothing building, the retrofit, and the replacement building. And it gives you it gives you the total emissions. This is over a 10-year time period. And it breaks it down by operational, which is the dark orange, embodied, which is the dark blue, avoided embodied, which is the light blue, and avoided operational, which is the light orange. And then it also charts it over time. So you can see the chart on the time at the end. And you can see like this particular project, the retrofit building paid off its initial investment of embodied carbon in 4 years, where it took the new building something like 15 years to pay off. So let's go through the different, so you start by entering project data. So you enter your state, your climate zone, or I think now we've got it tied to zip code. And each one of those, the state gives you your state's grid efficiency. The climate gives you your climate zone, or if the zip code will give you your climate zone. The primary use type will give you your CBEX classification. What is the building you're replacing? Might be a warehouse, might be an office building. And then there's the existing floor area and the operational timeline you want to look at. You can change all of these numbers, and it draws from data into the calculator. Then you enter about the retrofit building. You enter the different kinds of upgrades, and each one of these, I can't show it because it's not live, but I'm sorry, each one of these has a drop-down menu. So there's different choices, and each one of those has an embodied carbon footprint. You also enter your baseline performance, what you're aiming for. You do the same for the new building. In this case, the replacement building was this sort of mid-range mixed concrete and steel building, like a housing project, and your baseline. And then you also, there's an embodied emissions modifier. So do you have poor soil or using low carbon concrete? And these will also modify your results as well. And it plots it all out for you. So it takes, if you have information about your building, it takes about 10 minutes to fill this out, and you get a really quick snapshot on which one is better, when do they start paying off. And you can see that the retrofit never, the new building is never better than the retrofit. In this case, they never cross, but you can see the operating carbon of the existing building just continuing to climb. So that's it in a nutshell. And this is sort of to kick off. Then you're gonna get to see a really great case study from Christian. But I wanted the next steps. We're still working on this. We're still adding more drop-down menus. But we're trying to keep this a very simple tool, not so much for designers, but more for building owners trying to make a decision about whether to build or not. So with that, I think that's the end of mine, and I will hand it off to Christian.
Thanks, Larry. All right, give me a second here. You guys can see this okay? All right, so
Yep.
as Larry mentioned, was that a yes? You can see it? Okay, great. As Larry mentioned, I have a case study to show. So this is a Polytechnic high school in Portland, Oregon. The building was originally built in, I think, 1921, and it has been a Polytechnic high school for 100 years. So it's some fantastic programs. They have a foundry on the campus, and auto shops, and
I don't know what I said, but
metal shops.
I was eating, if anything.
And it's about 400,000 square feet in total. And we're pondering some of these questions that Larry's getting at in his new tool. And one of the precedents that we were looking at was a study done by it was called the Preservation Green Lab with National Trust. It's now called, I think, the Research and Policy Lab. But they published this study about 10 years ago, addressing this question of, how does building reuse stack up against new construction? And in their data, they had said for an elementary school in Portland that it would take about 16 years for a new building to catch up to an existing building. And so we wanted to dive into this a little bit more and see how that played out for this project. So the scope of the project was a good candidate for this comparison, because we had both new and retrofitted historic portions of the campus. So the area in the yellow on the left-hand side was portions of the campus that we are demolishing as part of the project, and in blue, building that section back new. And then the highlighted white portions of the campus are the landmarked historic buildings, and those are the ones being retrofitted and reused. So we thought that this was a great case study for looking at both the new construction versus the reused portions of the project. And the tool that we're using for that is Tally. So we're doing this project in Revit and using Tally on top of our Revit model to track the embodied carbon data through that. And so we got some interesting results in doing this. And we've done this twice now on the project, both at the end of schematic design and at the end of design development. And we'll be doing it again soon here. The project is currently in construction documents, so we will be updating this again at the end of that phase. The interesting thing was that we saw there was quite a bit of disparity between our SD data and our DD data, which you can see on the left-hand side here. So this is the carbon, we're looking at this as carbon intensity, so kilograms of carbon per square foot. And the biggest change that we saw was for the remodeled portions of the building, we saw a significant jump in the amount of structure associated with that. And then our new portion of the building, we saw that number come down significantly. And so the end result was that for the total project, total carbon intensity remained, relatively stable between the two phases, but the new and existing portions had some differences there. And one of the big factors that affected our results was that between schematic design and design development, there was a lot of additional structure added to the historic portion of the project. So the scope of our seismic improvements, which is the main driver for the structural work at the historic building, the scope of the lateral reinforcement needed in the historic building greatly increased. And because we're retrofitting the existing building, we're using concrete shotcrete walls to form the lateral bracing in significant portions of that structure. It's primarily wood frame construction, so it's not a heavy timber or a concrete frame like we would often see in buildings from that era. It's all light wood frame, and so requires quite a bit of seismic reinforcement. So there was a huge jump in our concrete and steel numbers associated with that phase. And so you can see here that the concrete is taking about half of our total embodied carbon for the project. When we track this against the CLF baseline for this project type, which we calculated at being about 53, we are still about a 44% reduction from that. So we are seeing a significant savings over the baseline, but the data's been kind of moving. And then we're comparing this project then against other high schools in our portfolio. So we got the two schools on the left-hand side here are typical new construction for us. So those have been coming in at about 30% below baseline typically for us. And then the two on the right here, Lincoln and Benson, both are retrofit buildings of existing historic schools. And so, you know, what we thought we would see when we started this was that we would be at about half the carbon footprint of new construction with our historic work, but really, you know, we're at about 75% of those new buildings rather than 50% like we were kind of anticipating. And it is largely because the amount of structural work, you know, in our region in the Northwest, we have significant seismic upgrades required in these old buildings. And so therefore there's a lot of new structure that goes into them when we retrofit them. And then we're also tracking the projects in the EC3 tool in addition to Tally, and keeping track of our operational carbon versus our embodied carbon. So this is the profile for Benson. The yellow is the embodied carbon, and the blue is the operational carbon over the next 30 years. And so we kind of hit the 50-50 point on that in about year 17 as we look forward to that. And then one of the things that we had really looked at in this study was to understand, similar to the charts that Larry was showing in the tool he's developing, was sort of how do we compare to the existing building? What if we did nothing to the existing building? We just continued to operate it at its current EUI versus the work that we're proposing to do on the project. And we also wanted to compare that against a complete tear down and replacement. And then also compare that then against a baseline code building. So the project will be LEED Gold certified. So it's very energy efficient, has a lot of innovative energy efficiency measures in it. And so for our proposed project and our new replacement project, we assumed the same level of energy efficiency, but for our baseline building, we assumed a code compliant building. And what we saw was that for the new project with the partial demolition and historic reuse, we're in between 20 and 25 years for our point at which we are then carbon positive compared to just leaving the building alone and continuing to operate it as it currently operates, which is not, you know, really a feasible option. The systems haven't been upgraded in nearly 100 years, and they won't last another 20 to 25 years. It requires a full replacement at this point. But we just wanted to track that. And you'll notice this is a straight line graph rather than the EC3 one, which is, you know, has a curve on it. The EC3 tool is assuming that the grid is getting more net zero carbon over time, you know, whereas our tool was a little more simple. So we plotted that as a straight line operational use. But that was sort of, you know, what we found in looking at this project. And you can see that, you know, the full replacement scenario, the dark blue on here, is off the chart, like doesn't ever catch up to the existing building's current energy use over time, even for a very highly efficient project. And so, so as part of this work, this is, you know, changing our approach to our projects and our practice. And so, you know, for these new projects that we're doing, we're looking at not just trying to evaluate where they are, but also looking ahead to developing low carbon specifications for them for our concrete, steel, and wood, and really trying to incorporate this thinking into our projects as we move forward. And that's it. And I'll turn it over to Don.
Okay, sorry about that. I got stuck in my slideshow and could not get back to my mute button. Thanks so much, Larry. And and Christian, for your presentations. That was very helpful for me. I've learned a lot and learned a lot of what I can share with my community-based clients. Great tools, great analysis, and data that my presentation will not have a lot of. So that's something that I won't have to repeat, and I can speed through some of those areas that are more quantifiable. Let me see if I can share my slideshow now. Wrong one. There we go. So you can all see that now. Good. Alrighty, so I want to talk to you a little bit today about how we begin to really approach more inclusive reuse, sort of envisioning inclusive reuse of yeah, sorry about that. Of the ideas of retrofit, repurposing, and reuse of existing buildings. Let me start the show from the beginning. These are images that you all recognize. You know, we have a culture of waste in Western society. It has not always been this way. This is not necessarily new, but it is a little old it's new in recent terms, but not very new in historic terms. We are now living at a time that as architects, and architects at my age, could actually see some of our buildings go into landfill. We are demolishing buildings that may not necessarily need to be demolished. So we have a construction industry waste problem as well as the normal household waste and industry waste from manufacturing, and the obsolescence culture that we also have within our society. The Fresno Municipal Landfill, so-called sanitary landfill, was one of the first in the country. It preceded the idea of an industry of landfill. And in some places, that landfill really became an industry unto itself, and began to become best practice for many communities as to how you shed your waste, what you do with it. So as you've heard in some of the previous presentations, we know a little bit about the embodied carbon that goes into buildings and how that embodied carbon can be saved by saving those buildings. It can take 10 to 80 years for an energy efficient building to overcome the negative impact of the demolition of an existing building. Some of these data points you've seen already. What goes into a new building, what is embodied carbon in that building from that point on, and how does the mining, foresting, manufacturing, and all the transport between any of those activities contribute to carbon emissions. This is something else that is saved, not just the embodied carbon, but the embodied carbon that includes the mining, foresting, manufacturing, and transportation and assembly on site, and the energy uses to do that. I was first exploring and became interested in green building, which was not called green building at the time. As a matter of fact, my master's thesis at UCLA in 1978 was the year that sustainability was coined. for green building. At the Wynwood Community College campus in Kaneohe was my thesis site. I looked at the campus that was a off-the-grid campus for a mental health hospital in Kaneohe, Hawaii, back in the early 1920s. They applied just about every green means to these buildings that we know today, as well as what they had to use without the technology and knowledge of what we have today. So applying these methods of green building and the design standards that they use for an off-the-grid campus was something that just seemed to be a natural fit for me. And actually saving some of these buildings that were purposefully and intentional designed to be responsive to the climate, directed and naturally ventilated towards the trade winds. I continued to use that format for new infill buildings and retrofitting and repurposing the existing buildings. It resulted in a re-envisioning of a green campus in a community that was a majority minority community, a community of color in Hawaii that then was able to witness a very necessary means and approach to construction in a place where just about every building material had to be imported to the islands. So transportation of that material was a much greater impact on carbon emissions. I also looked at neighborhood icons. So advancing, 30 to 40 years into my career, I continued to be exploratory on the idea of reuse of materials. And this comes from my background as a less than privileged individual and from a family that recognized that reuse of materials is critical. It is something that is a necessity when you have a scarcity of materials and resources. This is a Gee's Bend quilt made by Black quilt makers of South Carolina. And you can see here, if it were a little bit clearer slide, these are old dungarees. They're essentially blue jean material and other fabrics that were cast off materials that not only made functional quilts, but beautiful works of art. My mother would always say that Black people in the South were so resourceful in use of materials that they would use every part of the pig but the oink. In Black communities, we often inherited buildings of the previous tenants and residents of those communities. This is Synagogue Bikor Shalom in the Central District that was repurposed as the Langston Hughes Performing Arts Center in the 1970s. This is the 1908 Coleman School and also in the Central District of Seattle. My firm repurposed that for the Northwest African American Museum and with 36 units of affordable housing above in 2008, adding another 100 years to the life of this building that didn't go to the landfill. I've also explored the same kind of work in developing nations, particularly Africa. And in my trips to Africa, I noticed a lot of trash, particularly in the urban areas. I also, when I looked at that trash, realized that that trash was primarily the plastics of Western manufacture. There was an adoption in this even post-colonial era that was a legacy of colonialism and the Western idea of and culture of waste. This was not natural to Africa. As a matter of fact, Africa has adopted this culture of waste to an exceeding point that must be addressed. It is primarily unrecycled waste of Western manufacturing in a number of the countries in Africa, that there needs to be a change in the influence of how materials are used and reused, including our buildings. A traditional village, you don't see plastic bags. Everything is reused. If there's plastic bags there, they're probably being used for storage or some other purpose on site that you don't see them on the ground and thrown away. So you've seen this slide earlier, but you didn't see this one. So innovation and reuse is now becoming more of a cultural reinforcement. It's a reintroduction of reuse of materials, along with the necessity to apply green building and technology to the necessities of life, electric power in some of these rural villages. How can you be innovative in looking at the reuse of materials and not being reliant upon the import of manufactured materials from the West? Using local materials. This is a sandbag house in South Africa. This is a repurposing of abandoned grain silos in Cape Town, South Africa, into a museum complex. So how do we encourage approaches for innovation and expand our constituent base to communities of color, to emerging nations, and begin to break the cycle of a culture of waste and include the reuse and repurposing of buildings as part of our overall strategies? Thank you.
Great, thanks, Tom.
Those were all really, really fascinating presentations. Thank you, Christian, Larry, and Donald. We have about 15 minutes left to do some Q&A. And I should note also two things. One is for Q&A, I think that with the time that we have, it would probably be most efficient if you type your Q&A and then I can kind of field the questions to the presenters. And I'll kind of just filter through the chat and try to pick some ones that that might be applicable to everybody who are here. The other piece is that we have a happy hour series that we do at the Carbon Leadership Forum every other month on the months that we don't do webinars. The focus for the next happy hour, and again, this is kind of a very casual, just open forum for people to come and talk about topics that they're interested in, is going to be reuse. And so if there are questions that aren't necessarily answered in today's presentation, we're trying to create some space and opportunity for everybody to talk about you know, emerging research, questions, whatever, in a month when we have that upcoming happy hour. We don't have a link to share for it yet, but if you are subscribed to our newsletter, we'll be sharing it in our newsletter in probably about 2 weeks. Okay, so I'll review. I know that we already got some questions coming in through the chat, so I'm just going to take a look at those right now. And like I said, if you have other questions that have come up, please include them into the chat and we'll try to field them as efficiently as possible. So one of the easy questions is, Larry, when you were presenting, Ciaran Smith asked whether or not to build or not to build is available yet online. I think I know the answer to that, but maybe just a quick response from you would be great.
Yeah, it's not quite yet. It's not an online tool yet. Right now it's an Excel tool. We're trying to get further funding to turn it into an online web-based tool so it'll be more accessible. We have a beta version that we've released to some people to try and play with it, but we're still developing some of the menu pieces and some of the numbers. So I'd say it's probably a couple months off for at least the beta version to be more widely available. I don't know really how long it'll take us to get it up online as a tool. It's something I know nothing about, is making something into an online tool. So we have to find a consultant and find funding and all that. So that's the next step.
Awesome. Thanks, Larry. And then a question that we had for Christian during your presentation is about the Benson School. Were alternative structural systems evaluated for the shotcrete, carbon fiber wraps, other things like that?
We did look at other alternatives, and particularly, there was some back and forth between where we're going to take a steel or concrete approach to the seismic, the lateral systems. But we did not look at it specifically through a carbon lens. At the time that decision was being made, we weren't really up to speed with our LCAs. So it was, the alternatives considered were looked at primarily through the lens of cost, not carbon.
Yeah. Okay. Okay, so I'm going through the questions. One question that I actually had for you, Donald, was just whether or not you can tell everyone a little bit more about your work at the Nemi Initiative. It's clearly related to a lot of the topics that you brought up, and I imagine that you didn't include it for sake of time, but maybe just a brief overview of kind of the work that you all are focusing on right now would be great.
Sure. The Nemi Initiative, in very brief, is about repurposing. It's about repurposing land that is owned by the historically Black churches. First in Seattle, now we're going region-wide with it. There's a national movement to do that, to actually save what has been the center of Black culture and Black community in the United States has been the Black church. The largest provider of social services, the largest organizing entity in the Black community. But it is actually about building new buildings. So we will repurpose and we will save buildings that where we can, but this is about building new housing. So it's not necessarily part of this conversation, only in the sense that our first pilot project is going to be a net zero project.
And Donald, last time I mean not last time, but one of the times that I've spoken with you about this, there's, if the building itself is being reused, or maybe the building is built new, there are a lot of kind of community preservation implications around this too, right? Like maybe the non-tangible, more abstract, but still very real pieces of, how do you preserve space for people who historically have called this home that, through, new development practices, that isn't necessarily the case, right?
That's true. Preserving spaces, but I also wanted to add to that we are also saving the church buildings, many times that are community icons. And with the income that we feel will be generated by new development and use of their properties, they can afford to stay and afford to be able to make the improvements to their buildings that are necessary to keep them as neighborhood icons, and therefore entering into that conversation of embodied energy and the less carbon footprint that their total campus will have, including the introduction and reintroduction of conservation, of preservation, and acknowledging the scarcity of resources that the Black community has had in the past.
I want to add something. Just one of the things that we found in repurposing buildings is one of the not around carbon, it's around the community's attachment to the building. And so I think it's really important to recognize the value buildings have in a community, and using that as your organizing tool. The carbon argument is just like one more tool in your toolkit to go to the city and say, hey, look, we're saving carbon too. And you might get more points, but it's not to supplant the fact that the most important reason to save buildings often is social and community wise, not or carbon, really.
Yeah,
so
yeah, you're absolutely right, Larry, and that is the approach that I generally take. We know among professional groups that it is also about embodied carbon, but we know about community groups, it's about saving that building that I am familiar with. Having less change in the neighborhood from what we're witnessing now is great change in our neighborhoods. Restoring and saving, preserving that community icon, as I said, but also saving costs. We save costs, one, by not building a new building. We also save costs by improving the existing building to be more energy efficient.
So one clear bias I would say that we have in the presentation today is the architecture kind of design perspective. One of the questions that we have from Mustafa is around experiences that you can share about structural engineers' roles in these adaptive reuse projects so far, and how you hope to have them involved as Embodied Carbon continues to gain more attention. Does anyone have any comments on that?
I can speak to that. You know, I've had structural engineers coming to my eco charrettes, you know, integrated design workshops for our projects for a decade or more, you know, and they're always like, we are passionate about green building. How can we help? And they were always peripheral to a lot of the conversations we were having around, you know, energy efficiency, stormwater, you know, landscape habitat conversations, etc. Embodied carbon is the topic that they are really, you know, it's highly invested in and very responsible for. So it has actually really allowed us to engage with structure, with our structural consultants to have these conversations as we get into the projects to talk about how can we approach this from a low carbon standpoint structurally, because that's where all of the embodied carbon is. So, you know, what can we do? We're working with our engineers to develop, you know, concrete specifications that have significant carbon reductions in them, steel specifications that can do that. You know, mass timber, heavy timber construction is on the table for almost every project now for consideration. It has really changed the conversation with our structural engineers.
Yeah, and I would just say also that that besides changing concrete mixes or sourcing better steel, we really, since structure is the thing that sometimes tips you to a new building from a carbon standpoint, because it's so big, as Kristen found out, that looking even at really innovative new structural ways to upgrade a building, you know, not just saying it's got to be steel or shotcrete or steel, or, you know, that there may be ways to use heavy timber to brace buildings, or things that are much lower carbon and much lighter weight, frankly. An interesting case study that we've quoted a lot is that Portland building, the Edith Wendell Wyatt building in Portland. And when they removed the existing facade, which was concrete, to make it a better building and better sunscreens, they lightened the building so much they didn't have to do a full structural upgrade. So by taking off all this exterior weight, they were able then to do a much smaller structural upgrade and put a lot of that energy into this new sunshade for the whole building. So there's innovative ways to think about that. We really need the structural engineer's input, because it's not something I know how to do. So we need you at the table.
Yeah, and I'm exploring ways as well. How do you reduce the amount of concrete that you have in foundations? How do you do more column foundations and less total perimeter foundations? At the same time, looking at ways to deconstruct buildings. How do you plan a building today that, if it must be torn down or partially torn down, how do you deconstruct the building and reuse the materials of that construction in a new building?
So along this theme of kind of pulling other people in and being able to communicate this effectively, from Brian, we have a question about finding that clients are interested in evaluating embodied carbon, even if they're not pursuing LEED or have publicly stated goals. So how do you present the comparative information to clients if there isn't a clear or immediate cost benefit? Are there other communication strategies that have come up for you all?
I think there's always going to be a cost benefit. It just depends on how soon it is. and how lifespan and long it's going to be. There are others that just want to do the right thing. There are even community members that are now acknowledging the impact of carbon emissions and climate change. And they want to do the right thing, often can't afford it, but doing something is better than doing nothing.
Yeah. The approach that we've been taking so far is to present the information, right? So if we can present, as much as we know about the embodied carbon for the project, we may not be able to demonstrate a cost benefit to it, but we can present it, right? It's very much trending in how we still approach energy efficiency, but certainly we're approaching energy efficiency a decade or 15 years ago, where we can show the benefit, right? For energy efficient, like you can show the energy savings from an improvement, and there may not be a cost benefit, or it may cost more upfront and have a very long-term benefit in the long run from an operational standpoint. And if the decision to driver is budget, that's the dollars will always be the main factor in the decision. But having the information on the table allows clients who are really interested in doing the right thing, as Don said, to make those decisions, right? And say, actually, we would prefer to spend a little bit more upfront to make the right decision. We can make it work in the project budget, and therefore we're going to do it. And they can't make those decisions if they don't have the information. So the important first step is get the information on the table and present it to them.
And I'll add, it often results in healthier buildings and lower maintenance costs.